So we are going to discuss some problems on the uh, analytical function, whether the given function is analytic or not. If it is analytic, and then we have to find the derivatives using very basic definition of analytic function, that is f of z is analytic in case of Cartesian as well as in case of polar using the CR equations. Okay, so let me consider this first example, that is cos hyperbolic z. Okay, so this one I'll consider it as a f of z is equals to, or this we call it as a w is equals to f of z is equals to, we can consider it as a cos hyperbolic z. So we have two ways. So in polar form we have z is equals to r e to the power I theta, and in Cartesian form we have z is equals to x plus I y. Which one is simple? So that we are going to use, since here it is cos hyperbolic, so I'm going to use x plus iy. Okay, so whenever exponential comes, if it is complicated by Cartesian, we have to go for polar. If it is logarithmic, if it is difficult to simplify, then we have to go for polar form. So that is what you need to remember here. Okay, so here in e to the power z, it is simple. Again, we can go for this Cartesian form only. So while discussing the problems, we are going to understand that which one is simple to solve. So okay, f of z is equals to, here we have cos hyperbolic z is nothing but x plus I y we have. Okay, so again, as we have discussed so far, cos I x is equals to cos hyperbolic x. This is what we have discussed, very basic in the first introductory class only. Okay, so how can we rewrite this one? So this one I can rewrite it as a cos I into bracket x plus I y, like this we can write. If I multiply this I sign inside, cos I x, I into I square is nothing but minus 1, so into y. So like this we are going to get. Again we have cos A minus B formula. Okay, so cos A minus B is nothing but cos A cos B plus sin A sin B. So that is how we can rewrite this as a cos Ix into cos Y, okay, plus sin Ix into sin Y, like this we can write. Again, cos Ix is nothing but what we can write it as a cos hyperbolic x into cos y plus sin Ix. We know this sin Ix is nothing but I sin, okay, hyperbolic x, I sin hyperbolic x. So I can write this as a I sin hyperbolic x into sin y. Okay, so now this becomes a real part and this becomes imaginary part. Okay, so here, so this is nothing but we can write it as a u plus I into v. Okay, so u is real part and v is a imaginary part. Okay, so this we are going to use for further simplification. So here u is equals to real part we are going to consider, that is cos hyperbolic x cos y, and v is imaginary part, so excluding that I, what we are going to consider here sin hyperbolic x and sin y. Okay, then we have to find CR equations, means u I have to substitute and differentiate with respect to x. So with respect to x, cos hyperbolic x differentiation is sin hyperbolic x. So since we are doing partial differentiation, I have to keep this cos y as it is. Okay, again u I have to differentiate with respect to y partially. So cos hyperbolic x as it is, cos y differentiation with respect to y is minus sin. So therefore what we are going to get here, minus this cos hyperbolic x as it is, differentiation of cos is minus sin y. Okay, So again, similarly, v with respect to x, we are going to differentiate v subscript x. Okay, so with respect to x means sine hyperbolic differentiation is cos hyperbolic x. Sine y we have to keep as it is because we are differentiating with respect to x here. And again, v with respect to y means sine hyperbolic x I have to keep as it is. Sine y differentiation with respect to y, that is cos y. Okay, we know CR equation ux is equals to vy, so these two are equal. Okay, and vx is equals to minus uy means these two are equal. So therefore what happens here, CR equations means Cauchy-Riemann equations, okay, satisfies. Okay, so if this satisfies, what happens, f of z is equals to what we have taken, cos hyperbolic z is analytic. Okay, so if it is analytic, we have to find the derivative. So w is equals to, we have f of z is equals to what we have, cos hyperbolic z. Okay, then its differentiation dw over dz is equals to f dash of z, which we can write it as a u subscript x plus I into v subscript x. This is from equation 2 of the CR equation while we are discussing CR equation. This is from equation 2. Okay, so we know already ux is equals to this one. Okay, so this is from equation 2 as we remember. Okay, f dash of z is equals to ux plus ivx. Ux we know from this. Okay, vx also we know from this. Okay, so those things we are going to substitute it here. Okay, so now we are going to substitute those terms, that is f dash of z is equals to ux we know, that is what we have, sine hyperbolic x cos pi plus I into vx we know, that is cos hyperbolic x sine y. Okay, so further we need to simplify this. Okay, to simplify, what we are going to do, multiplying and dividing by I we will do. Okay, so it gives me I, okay, over I, this is sine hyperbolic x cos y, okay, plus this is I square, okay, over I cos hyperbolic x sine y. So this 1 over I will take common, so I sine hyperbolic x, okay, I sine hyperbolic x cos y. So this I square is minus 1. Okay, I have taken common, so cos hyperbolic x sine y, like this we are going to get. So this is 1 over I. Again, I sine hyperbolic x is nothing but what we have, sine ix. Okay, this is cos y minus this is cos hyperbolic x is nothing but cos ix, okay, sine y. This is again what we have, sine a cos b minus cos a sine b. How can we rewrite it as, so this one we can rewrite it as 1 over I, okay, sine of ix minus y, because cos sine a minus b formula it is, okay, sine a cos b minus cos a sine b. So that is the formula. Again, if I take this I out, that is what we are going to get here, 1 over I. Okay, so what we are getting here, sine I, if I take I x, okay, plus I. It happens because if I multiply I into I square is nothing but minus 1. So this I have taken out. So now this one again sin I x form. So this is nothing but x plus iy is nothing but a z. So 1 over I, is that okay? Okay, this what we can write sin I z. So sin iz or sin ix both are nothing but I sin hyperbolic only, I sin hyperbolic z divided by I. So this I and this I gets cancelled. Sin hyperbolic z. So this is what we are getting. So this is the derivative f dash of z. So f dash is a differentiation of a cos hyperbolic z is sin hyperbolic z. This in real also we have done differentiation of sin hyperbolic x is cos hyperbolic x and cos hyperbolic x is sin hyperbolic x. That is what we have discussed in real. The same way we are going to discuss it in a complex also. Okay, thank you.